But before that, for the today's subject, I will go through quickly the different characteristics of flower. Okay, so mm, okay. So this flower mm, flower has different holes. Okay, those calyx, corolla, androecium, gynoecium. This calyx and corolla, they are the accessory organ. Calyx and corolla are accessory, and androecium and gynoecium, they are essential organ. Androecium is male, and gynoecium is female reproductive organ. The flower may be complete, a complete flower having all the four holes. So that is, they are having calyx, corolla, androecium, gynoecium. If any one of them is absent, then it is incomplete. Okay, and the flower is all the complete flower. They are bisexual because complete flower has all the floral parts. All right, they are, and that is a bisexual flower. They have androecium and gynoecium both. In some of the flower, that in particular family, they have either androecium or gynoecium. Those flowers are unisexual flower. So unisexual flower will be incomplete flower, is it? Because they will be missing either androecium or gynoecium. So there is flowers maybe unisexual or bisexual, and also some flowers are there where the androecium, gynoecium both are absent. Those flowers are called neuter flower. That is the absence of all the mm, androecium, gynoecium both are absent. This is found in some of the flowers in family Compositae. Okay, sunflower family, they have this unisexual flower, either male. This male flowers are also known as staminate flower. Staminate flower because they uh, they have stamens. Stamens, that is the component of androecium. So that's why they are called staminate flower. This is found in case of cucumber, pumpkin, castor. There is on the same plant, male and female flowers are produced. In the our Scott fruit, Scott plant also, there is male flower and female flowers are different. Those flowers of which are female having gynoecium only, they are also known as either female flower or pistillate flower. Okay. So in the same family, cucumber, pumpkin, castor, squash, in them there is female flower, pistillate flower is present. So male and female flower. The another important point is there, that floral uh, symmetry. Okay, symmetry of the flower, and based on that, the flower a flower may be mm, a flower may be actinomorphic. All right, a flower may be actinomorphic which has a radial symmetry. That radial symmetry is flower base, that one is the circular, and all the floral parts are arranged in a definite regular pattern. Okay, those flowers are symmetry. They have radial symmetry and the flowers are actinomorphic. In this case, what happens if you say cut the flower through any plane, then the flower will be divided into two equal halves. Say if we divide this through this line, say this side 2.5 petals, this side 2.5 petals. If I divide from this line, this side will be 2.5, 2.5. If divided from this line, then also it can be divided into two equal halves. So they have radial symmetry and they are called actinomorphic flower. This master, dhatura, chili, they are they have radial symmetry and they have this actinomorphic flower. The opposed to the actinomorphic flower, there is one is called zygomorphic flower. Zygomorphic flower, they are bilateral. They have bilateral symmetry. Means they have two from any one plane. These flowers can be divided into two identical halves, like the what we find in case of pea flower. Okay, in pea flower, the flower can be divided into two identical halves only through one plane, anterior posterior plane. This is anterior, this is posterior of this, and so it can be divided this side 2.5, this side 2.5. But if you divide this through this plane, okay, then you cannot get the two identical halves. This type of we find in the pea family, that is Fabaceae. In this we find the zygomorphic flower. There are many other also, but for your known the from the syllabus, this is the in the pea family that the zygomorphic flowers are there. The flowers, some of the flowers are there which cannot be divided into two equal halves through any of the plane, and they have their petals, sepals, and androecium, gynoecium are arranged, and shape size are so different that you cannot get two identical halves through any of the plane. So those flowers are known as asymmetric flowers, and they are irregular flowers, and it is Cana. This this one actinomorphic flowers, they are regular also, regular actinomorphic, and they have radial symmetry. Okay, this one thing is that merosity of the flower, what is called merosity of flowers. So in the merosity, that how many in a floral holds, how many parts are there. If a calyx consists of how many sepals, petals, how many petals, androecium, how many, that is there in each of the rings. So this is based on that flowers are trimerous, tetramerous, or pentamerous. Trimerous means they have three or multiple of three. Tetra means four. They have four or multiple of 4. 4 or multiple of 4. 3 or multiple of 3. Okay. And pentamerous, they have 5 or multiple of 5. So they have trimerous like 3, 3, 3. Maybe calyx, sepal 3, petals 3, androecium 3, gynoecium 3. So, or multiple of 3. Multiple of 3 means that may have 6, 9, 12. Okay. This tetramerous 4 and multiple of 4. Pentamerous 5 and multiple of 5. Say, so this is one of the important criteria is that the trimerous flowers, they are the characteristics of monocotyledonous flower. Trimerous. Say here, trimerous flowers are characteristics of monocotyledons, whereas tetramerous, this tetra and penta, tetramerous and pentamerous, they are for the dicotyledonous flowers. So, by observing, by counting the number of petals or their sepals, you can at least identify that this flower or the plants belongs to which group. This is monocot or dicot in the angiosperm. Okay, this is very, very important. So in monocot, we find trimerous flower. This is then another thing is that the position of the ovary, position of gynoecium, relative position of floral holes in respect to gynoecium. In compared to the female reproductive organ, what is the level or position of other floral holes, that is calyx, corolla and endoecium. Okay, so whether they are at the same level or they are below or above. So based on that, the flower may be hypogynous, perigynous and epigynous. So hypogynous, hypogynous means below gynoecium. That is androecium, corolla, calyx, they are below the level of ovary. So naturally the thalamus on which the floral parts are attached, seated there, the thalamus is slightly convex type, raised. So the ovary is here and all other will be naturally below the level of ovary. So they are called the hypogynous flower. In this case, ovary position is superior. Okay, say here mustard, China rose, brinjal, all are hypogynous flower. Then it is there is a perigynous flower. In perigynous, peri means around the gynoecium. They are little bit, this thalamus is slightly saucer shape or cup shaped structure. Okay. Here you can see this one, this three. Okay. This one is hypogynous flower. And these two flowers, what happened? This is the thalamus. This thalamus is slightly cup-like structure, okay, and the calyx, corolla, androecium. Calyx, corolla, androecium is around the ovary. So they are called the perigynous. These things, perigynous flowers, they are present in case of mm, this perigynous flowers are there in the pea family also. All the plum, rose, peach, okay, rose, peach, and pea, etc. There is Perigynous ovary is half inferior, also sometime called. And the third one is the epigynous. Here is epigynous. Epi means above, gynous, above the gynosium level. So here what happened, that the ovary is completely covered by, this is ovary is completely covered by the thalamus. This one light green portion you can see, this is thalamus. Thalamus has completely covered and it is fused with the ovary wall. And then the calyx, corolla, androecium, they are at the top of the ovary. Okay. So ovary is below the all other floral part. This is the inferior ovary. Ovary is inferior. This thing is we find in case of, this is guava, cucumber, and the florets of sunflower. Ah, guava, cucumber, and florets of the sunflower, this pomegranate, pomegranate, all the cucumber type of cucumber, pumpkin, and the squashes, you what you will find that when the flower is coming up, in these usually there is a male and female flowers are usually different. In this cucumber you will find that from the beginning the there is a fruit, and on that fruit the flower is at the top, okay. So that is, and the fruit is there at the base. This you will find in Scott also, and all type of pumpkin. So by this fruit below the ovary, below the petal sepal, okay, you can identify from the beginning. So this is the epigynous flower. All right. This perigynous and epigynous, one slight difference is that the in case of epigynous, the thalamus cup, this one is completely fused with the ovary wall. But in these perigynous cases, the thalamus wall is not fused with the ovary. They are free. So this is epigynous flowers, and then there is one thing is called the estivation. Estivation is the relative arrangements of the member of either calyx or the corolla, their relative arrangement. And this is there are several types: valvate, twisted, imbricate, and vexillary. You can see from the diagram here. mm, say so this one, this is the this is valvate. Okay, number one. Here the petals, here in this showing the petals, their arrangement, that the all the petals in the bird, they are just their margin not overlapping, margin are just meeting each other. Okay, this one of course is showing polycephalous condition, but here the petals or sepals, they are not overlapping, but they are just meeting. So this is called the valvate, number one. Here in this case, number two, this one is valvate. This is twisted. Twisted, of course, written here, valvate, twisted, imbricate, and vexillary. Here in the twisted, in each of the petals, say, overlap, one margin is exposed, one margin is covered, one margin is exposed, one margin is covered, one exposed, one covered. In a regular fashion, that is, in a particular direction, one margin is, it is one is covered by the previous one, and the one margin is covering the next one. So this is called the twisted. And there is imbricate. In case of imbricate, what happened, that see this one petal, both the margins are inner, and this petal, both the margins are outer. Means here what happened, one is completely inner, one is completely outer, and others are in a twisted fashion. This is called imbricate. This type of things are found in most of the leguminous family. Okay, and the next one is very very important for you, that is the vexillary. Vexillary type is found in case of pea here. Okay, pea here in this case, the petals, and it is found only found in case of corolla. Okay, in calyx, this type of estivation is not present. So this is one, they have one very big posterior petal, this one. This is called vexillum or standard. These two are smaller than this, two are lateral. Okay, they are called wing, and two in the front. This is the anterior. They are the smallest and covered by the two lateral wings, and this one is known as kill. This type of estivation is called the vexillary estivation, and it is found in the family Papilionaceae. So in papilionaceous flowers only this one is present. So this is the twisted imbricate vexillary. Then androecium. Androecium, that is the male reproductive organ, and there are the unit of androecium is made of stamen. Okay, a stamen consists of a filament and anther. Anther, in most of the cases, it is bilobed. This within the anther, pollen grains are produced. Pollen grains or microspore are produced. One important thing is in some time that the anthers or the stamens are sterile. That is, they do not produce functional or the fertile pollen grain. Then this sterile stamen is called staminode. Okay, staminode. In a flower, there may be a different number of staminode may be present, not in all the flowers. This maybe the stamen is fully developed, but within the anther, pollen grains are produced. They are non-functional. Or sometime what happened, the anther is not formed, or maybe this totally the stamens does not develop. The stamens may be sometime attachment with the one we call adhesion. Adhesion, that is, the stamens are attached with the other holds, member of the other holds. That is, the endoecium is attached to petal or to the gynoecium. Then it is called the adhesion. Mm, So here a very common thing is a condition that is called the epipetalus. Stamens are attached to the petals by their filament. Okay, with this portion, then this is epipetalus, and these are in Solanaceae it is found, so brinjal, potato, datura here. And sometime it is called epiphyllus. Actually, epipetalus, epiphyllus, the same thing. But what happened in case of monocot like this onion, lily. So in this case, the calyx and corolla, they are not very distinct. We cannot identify them as that this is calyx, this is corolla. In that case, we call it as a perianth. And when the endoecium stamens are attached to the perianth, in that case we call it as epiphyllus. Instead of epipetalus, we call epiphyllus. So then endoeciums stamens are polyandrous when they are free from each other. This is a very common case in most of the flowers. This is found. Then these stamens may be united. We call cohesion of endoecium or cohesion. Okay, where the endoecium, remember, they are fused together in various groups. So there is one is called Monodelphus. Mono means one. So all the stamens, they form one bundle. This one bundle, this one is found in case of that China rose in Malvaceae. One bundle in China rose, that is hibiscus family Malvaceae. This is characteristics of Malvaceae. Sorry. The next is, after one bundle, then two bundles means form a two bunch, and this is called Diadelphus. Diadelphus. And in Diadelphus condition, this is present in P family. That is in Papilionaceae, Papilionaceae, or it is also known as Fabaceae. That is in the P family, this one is present. In the P family, there are 10 stamens, and in this 10 stamens, 9 plus 1. 9 are united into one group, one is free. So this is Diadelphus condition, and there is one is called into more than two bundles, that is called the Polydelphus condition. It is found in citrus, castor. Okay, so there is many many bundle or more than two bundle, greater than two bundles. This is poly means many, Polyadelphus. This one is in case of citrus and castor, then silk cotton. In this it is found. So there is, and another thing is that the in all the cases, uh, in some of the flowers, the length of the stamens are not equal. Okay, so stamens may be of equal in length or not equal in length. They may be irregular also, means different stamens have a different length. But in some of the flower, this different length, they are in a particular, in a fixed pattern, and that is in that there are two cases. One is called Didynamis and another one is Tetradynamis. Didynamis, here the di means two and tetra means four. Here dynamis is strong, longer. In this case, two is strong, that is too long and too short. This is found in case of salvia. They have four stamens, one usually a staminode, so too long and too short. And tetradynamis, here this is found in mustard. In the mustard family, cruciferi, there is or brassicaceae. In mustard family, out of the six stamen, four long and two short. Okay, so this is tetradynamis. In tetradynamis condition, the diagram will be say like if we draw uh, not at us, they are free. 4 and 2 are short. So this type of condition, when 4 long, 2 short, then it is Tetradynamis found in the mustard. Now come to the some of the character of the gynoecium, that is the female reproductive part. This consists of one or more carpel. This when it is more carpel, then there are two conditions. If more than one carpel, either one carpel, when it is one carpel, we call monocarpellary. Okay, gynoecium that is made of carpels. Carpels may be one or more. So one is monocarpellary, and the more than one is called polycarpellary. Polycarpellary. And in polycarpellary, there are two conditions. One is all these carpels, they are fused and they are free. The carpels are fused. When the carpels are fused, the condition is called syncarpus. And when the carpels are free, they are known as apocarpus. Syncarpus condition we find in China rose. Okay, we find in lady's finger, right? All this we find in brinjal, brinjal, potato. These are the syncarpus condition, that one, the carpels in tomato, you usually can see that 2 to 3 chambers are there. When you cut a lady's finger, you can find 5 chambers are there with seeds. When you cut orange, there are several chambers. Okay, so this type of things are, that is the fuse and free one more, that is this is found in case of rose, apocarpus condition. So apocarpus, rose, lotus, or syncarpus, mustard, tomato, lady's finger, China rose, etc. This ovary, after the fertilization, make the fruit, and within the ovary there is that there is develop the ovules, which later on mature into seed. This arrangement of the ovules, okay, this is known as one thing that is called the placentation, because the ovules are attached to the ovary wall through a special tissue. That tissue is known as placenta. Placenta is a special tissue with which ovules are attached to the chambers of the ovary, to the ovary, maybe to the ovary wall or to any of the part of the ovary, but it is within the chamber, within the locules. So different types of placentations are there. There is a marginal, axial, parietal. Okay. parietal placentation, free central placentation, basal placentation. Here is a diagram for the okay. See this one here in this one, this is the marginal placentation. This one is marginal. Okay, this is usually monocarpellary, as you find in pea. When you will peel pea for your kitchen for cooking, then you see that all the seeds are attached to one line. Okay, particular joint on the ventral side. On the ventral side of the ovary, which is one chambered, it is monocarpellary, and they are attached. So it is the characteristic placentation of the family Fabaceae or the Papilionaceae family. Okay, marginal. It is found in pea and all the beans. Okay, all the beans, pulses, this type of placentation you will find. Then there is exile placentation. In exile placentation, the ovary is, here the gynoecium is polycarpellary syncarpus. That is, they are united, fixed, and there are chambers. See here it is shown three chambers, maybe two chamber, maybe four chamber, five chamber, and the ovules. Okay, the ovules are attached. You can see carefully this ovules are attached at the central axis, but there is a partition for each carpel and chambers are there. So it is syncarpus and multilocular ovary in which the ovules are attached at the central axis. So this is called the exile placentation. It is in China rose, tomato, lemons, etc. Right. Then come to, there is one which is called the free central, this one, same, this one and this one, this is the free central. The only difference is here, the only difference is here the ovary has a chamber, partition wall is there, but here the ovary is one chambered and there is no partition wall, but ovules are attached to the central axis. This one is in case of dianthus and primrose it is found. This is free central. The next one is parietal placentation. One I have explained first the free central, okay, after exile, because there are similarity. In parietal, that is the parietalia, that inner wall of the ovary, or on the peripheral part. Example, mustard, argemone. So here is this ovules are attached to the walls, inner walls of the ovary. All these things are the cross section of the ovary. Okay, so ovules are attached to the inner wall or the parietalia of the ovary. This type of things you can find um, uh, find in case of, say, like a papaya. Papaya also you will get this parietal, you will get in pumpkin also. Yes, in the pumpkin also you will get this type of parietal placentation. You will get the parietal placentation also in the cucumber. Okay, so this is then come to free central parietal, and there is one is called the basal. Here the ovary is one chambered. This is usually it is bicarpellary syncarpus, and there is single ovule, that is single seed, that originate from the base of the ovary. This one is the ovule, and it is arising from the base of the ovary. So this is called basal. This one is characteristic feature of family Asteraceae, right? Family Asteraceae, that is the sunflower family. In the sunflower, you eat the sunflower seeds, is it? Sunflower seed, and you get only one seed in each of the fruit, that is small fruit, so that you eat. So this is the placentation, and then come to the fruit. Fruit is, that is the mature ovary which developed after fertilization, and the seed developed after fertilization from the ovule. If a fruit developed without fertilization, say pollination, fertilization does not take place, but still the ovary mature into a fruit, then that one is known as parthenocarpic fruit. The fruit is parthenocarp or parthenocarpic fruit. In this parthenocarpic fruit, usually there is no seed. Okay, because fertilization does not take place, so the seed is usually does not produce. In a fruit, there is fruit wall. Okay, the fruit consists of the fruit wall or pericarp. This is nothing but the ovary wall, and the seeds within the fruit there is seed in angiosperm. Fruit formation only takes place in angiosperm. In other group of plant, in gymnosperm, pteridophyte, bryophyte, algae, in those there is no fruit formation. Okay, so fruit formation is characteristic feature of angiosperm. This pericarp is the wall of the fruit. This pericarp may be thin or thick, may be dry or fleshy. Okay, and based on that, fruit also has been classified in different way. This pericarp sometime is differentiated into epicarp, mesocarp, and endocarp. Okay, but in all the fruit, these three part may not be distinct. Okay, so in some of the fruits it is only distinct, in others it is not very distinct. But pericarp is made of epicarp, mesocarp, and endocarp. This uh, fruit is of different type. There is fruit, maybe simple fruit, maybe aggregate fruit, simple fruit, aggregate fruit, simple fruit, and multiple fruits. Okay, this there is in the simple fruit, one fruit developed from one flower. That is the whatever is the gynoecium is there, that ovary that give rise to one fruit. So this again, maybe this simple fruit may be fleshy or dry. Fruit may be dry fruit, maybe fleshy fruit. Okay, so the fruits of mango and coconut, they are one type of fruit which is known as drupe. This fruit develops from monocarpellary superior ovary, and they are single seeded. Drupe is, so you have to remember, drupe is single seeded, developed from monocarpellary ovary, and ovary is also superior, means flower is hypogynous. And in the mango, what happened? In mango, that what we peel, that is the epicarp, the fleshy portion that we eat, that is the mesocarp, and the endocarp is stony, very hard. That one we throw along with the seed. Okay, we don't eat. So here the in mango, pericarp well differentiated into outer epicarp, middle fleshy, edible mesocarp. Fleshy and edible mesocarp. And the inner hard stony endocarp that is not used. In coconut also, mesocarp is not edible. Say this coconut and mango and coconut. No, for you it is that two different type of fruit, is it? And sometime if we ask you to buy fruit, naturally you will not buy coconut. No, that is not. We usually take those fruit that is used immediately, ripe one, or without cooking, the ripe one we can eat, ripe or unripe green one. Mm. But all this botanically, all this whatever is a mature ovary, that is fruit. Mm. Fruit may form in some cases vegetable, in some cases it is fruit that we use. So this in terms of botany, the coconut and the mango, they are same group, and they are drupe. But what happened in case of coconut, epicarp is very thin. Epicarp is very thin. Okay, and mesocarp is fibrous. Okay, that spongy fibrous portion, major part of the coconut, what we throw, that fibrous portion is mesocarp. That is not edible. And this fibrous portion, mesocarp, is the source of coir, is it? And This next is the endocarp. Hmm. Endocarp is the hard stony shell, that is the shell of the coconut. That one is endocarp. That is also not edible. So in case of coconut, the fruit wall, that is not edible. If we say that the fruit is not edible, it is the seed is the edible portion, and here that the portion we eat after breaking the shell, that white fleshy portion, that is the endosperm. That white fleshy part, okay, that is edible. And also the coconut water, this is also endosperm. So in coconut, it is the endosperm is edible portion. Here you can see the, okay, see this one is, this is the mango section, that epicarp. Mesocarp is, this is fleshy portion that we eat, and here is endocarp, that black line, endocarp. This is the part of the ovary wall. So this endocarp is hard and the seed is inside. In mango, the seed is not edible. It is the mesocarp is edible. But in case of coconut, this is of course after peeling. Here the mesocarp, that some fibers, thread-like things is shown, that is the mesocarp. And this hard portion, hard shell, this shell is the endocarp. And here that white portion, this is the, this is, that is in the seed, and in the seed it is actually the, this is endosperm that we eat. Okay, and here is the seed. This is seed of gram. Here in the seed, that what is the seed is, that is the mature ovule, is it? And a seed consists of an embryo plus seed coat, or it is also known as testa. Right? and they may or may not endosperm. In the seed, this one may be present, may not be present. When the endosperm is present, this one is called endospermic seed. If the endosperm is not present in the mature seed, then it is called non-endospermic or X-albuminous seed. So this one is gram seed, that what it is shown from the outside, this brown coat, this is the seed coat or testa. This one is this one is formed by that the integument of the ovules. Okay, and here in each of the seed we can find a mark. This mark is the hilum. Hilum means this is the point of attachment of the ovule or the seed to the ovary wall. Okay, so this is called the hilum mark. And we can see one very small hole, very small hole. That one is the micropyle of the ovule. Okay, and after peeling, that is after removing the seed coat, we can find the embryo. All right, in the pea seed or in the gram seed, in the mature seed, we don't get endosperm. So these seeds are non-endospermic or X-albuminous. In this, there is, after peeling the seed coat, we can get the embryo. And the embryo, there is one or two cotyledon. And there is the main portion of the embryo is the embryonal axis. Embryo consists of embryonal axis plus one or two cotyledon. Okay, so this is the embryonal axis, and these are here two cotyledon. Cotyledon is attached to the embryonal axis. Okay, here. And this point of attachment, above the point of attachment of the cotyledon, this portion is epicotyle, and this portion below the point of attachment, this is hypocotyle. So there is epicotyle and hypocotyle. Okay, then at the end of the epicotyle, there is the structure, that portion we call the plumule. Plumule will give rise to the shoot system. Stem leaf branches will develop from the plumule. And the other end, that is in the hypocotyle, the other end, there is radicle. Okay, radicle give rise to the primary root. So root develop from the radicle. So this is the structure of the dicot seed. In the monocot, there is typical monocot seed. There is a little bit of differences there. Okay, see here, this is maize grain. All right, this maize grain, a example of monocotyledon seed, and we will see what. So here it is monocotyledon, means there is only one cotyledon. So this seed, actually what happened, that in case of most of the monocot, particularly in the maize grain, wheat grain, this ovary wall and the seed wall, seed and ovary, they are fused together. Wall of the seed and the ovary wall, they are fused together. That's why they are completely mixed with the seed and fruit. So they are usually called the grain, food grains, so that maize grain, wheat grain. Okay, and here you can see this one is, this is the, this is the wall of the ovary. All right, and this portion is the seed. So it is fused, and the major portion of the maize grain, this is occupied by the endosperm. So in the mature seed, here endosperm is present, and so this is, maize grain is an example of endospermic seed or albuminous seed. Albuminous seeds or endospermic seed. Okay, major part is this, and then there is embryo. This one is embryo. Embryo occupy very small space in this maize grain. This is the enlarged view of the section of the maize grain, and this is the seed coat and the fruit wall fused. See, seed coat and the fruit wall fused. This is outer layer, and just below this, in this seed, there is a proteinaceous layer which is known as aileron layer. Aileron layer. This is important proteinaceous layer. This one is around the endosperm, and the major portion, this part is the endosperm. The embryo that occupy a very small space, and in this embryo, as it is monocotyledon, so there is only one cotyledon, and this cotyledon, naturally it will be lateral in position on one side, and this one is actually like a shield and a slightly concave, convexo-concave structure. That is the saucer plate-like structure. So this is one large, okay, and this cotyledon is called the scutellum. So name also is a special name has been given to the cotyledon, that is the scutellum. And on one side, that is the embryonal axis is there. In the embryonal axis, as it is in the dicot also, uh, here is plumule and is radicle. Radicle is this one. This is the embryonal axis. So this is radicle, and this side is plumule. Another important feature in this maize grain, or this monocotyledonous seed. Okay, there is that the plumule and the radicals, they are protected by a membranous covering, and this membranous covering of the radicle is known as, this one is the covering of the radicle, and this is known as coleorhiza. Rhizon means root. So this is coleorhiza, and the membranous cover of the plumule is known as coleoptile. So coleoptile and coleorhiza. You should be very careful about this, which one is coleorhiza, which one is coleoptile. Okay, so these are the structure, and now let us see, because all these things characters that will come for the multiple choice question. Okay, now let us uh, still, yes, still some time is there. We have to finish, we have to practice some of the questions. Let's see. Mm, okay, in the previous class, we are doing some of the questions here. Here it is, say, come to this question. Today, let this question, choose the incorrect match from this. Matching here is, some characteristics of flower has been given, that is gygomorphic flower, asymmetric flower, inferior ovary, superior ovary has been given, and this side in the this column there is examples. So zygomorphic flowers, it is having bilateral symmetry. Which one? Incorrect one we have to say. Is it P and Gulmohar? Say P is family from the Fabaceae. In this P, Gulmohar, B in Cassia. In these, I told that is the flowers are zygomorphic, right? So this is correct matching. Asymmetric flower in Canna. This is also a correct matching. Inferior ovary. Ovary is inferior. P. In the P, flower is Perigynaus, of course, but this is half inferior to superior in case of P. This is the incorrect matching. Superior ovary, hypogynous flower, mustard, China rose, and brinjal. This one is correct example. So our answer is this, that inferior ovary P is the incorrect match. Next question, there is Tetradynamis. Tetradynamis condition, that is the four long and two short, four long two short stamens, four long two short is Tetradynamis. Okay, Tetradynamis condition is found in mustard. and in mustard is belongs to family Brassicaceae. Okay, this Brassicaceae is earlier name was cruciferi. All right. So say the in the question maybe options, maybe the family name or maybe the plant name. So you have to be ready with both. It is maybe given that mustard or the cabbage, cauliflower, this belongs to this tetradynamis condition. In labiati, in this labiati, didynamis condition is found. That is too long, too short. Here, labiati or lamiaceae. This is the labiati, also known as lamiaceae, new name, because all the family names end with AC in the modern rules. So lamiaceae, this labiati is old name. So here it is not ending with AC. So new name has been given lamiaceae. Earlier name of Brassicaceae was cruciferi, not ending with AC. That's why the name rename as Brassicaceae. So it is CEAE. Here it is didynamis. Too short, too long. Too long, too short. Didynamis, too long, too short. Okay. The next one is marginal placentation. Ovules are arranged in marginal placentation. Where do we get? In P. So ovules are arranged along the inner wall of the carpel in syncarpous ovary. This is the P is monocarpillary. Okay, P is monocarpillary. So there is no question of syncarpous things. Along margin of single carpel. Yes, this is marginal along the margin of the single carpel. In middle of the ovary, no. On the base of the ovary, no. So this is the answer. Next, this we have done. Okay, now this one we didn't do. Say from here, keel is the characteristic feature of the flower of key is found where, in which flower? Here the flower of tomato, flower of tulip, flower of indigofera and aloe. Which one? This was CBSE AIPMT that 2015. It was asked in AIPMT. Now, of course, AIPMT also under NTA. So, single exam. So, this one,
C, sir.
C. Yes, indigofera, because by here, this one, this keel is in case of Fabaceae, that papilionaceous flower. Papilionaceous flower. In papilionaceous flower, it is found indigofera, that which produce the dye, indigo dye. Okay, this is a dye producing tree. From the wood of this indigofera, dye, blue dye, indigo dye is produced. So indigofera belongs to that Fabaceae family, and the keel is found in Fabaceae. So here the problem is that if you don't know the plant that belongs to which family, then also you cannot answer. So common example has not given. This is choose the incorrect match. Here again incorrect match. Gygomorphic flower P. This is the same one. Okay. That we have already finished. Radial symmetry is found in the flower of NEET 2016. This one asked this question. Radial symmetry. Radial symmetry is actinomorphic flower. Actinomorphic, and they are also known as the regular flower. Okay, and this is found in the family. Here, those given trifolium is belongs to Fabaceae. Pysium, that is Pysium is Fabaceae P. Cassia is sizzle penny, that is also Leguminosae. All these three, they are zygomorphic. Zygomorphic and having bilateral symmetry. Okay. Only the brassica that belongs to family no, cruciferi, this one is having radial symmetry. This one is having the radial symmetry. Right? The next